One of my COVID projects has been scanning photographs and basically trying to organize all of my digital files. And I noticed a very distinct trend. I love to take pictures of nature, especially close ups of the patterns of flowers and so on. And I got to thinking, if you look around, there are a couple of patterns that you'll see everywhere, both of them based on the Fibonacci sequence. Fibonacci was the son of an Italian merchant born in 1190. Through his writings and studies, around 1200 through 1225 or so, he introduced Europe to Arabic numerals. Thankfully, this replaced the Roman numeral system. As you might expect for the son of a merchant, much of his mathematical work was related to commercial issues, such as converting currency and calculating profits. He came up with the Fibonacci sequence. Each number in this sequence equals the two previous numbers added together. So the sequence is as shown here. The sequence comes from a hypothetical question. How many pairs of rabbits will be born in a year starting from a single pair if each month each pair gives birth to a new pair, which becomes reproductive from the second month? So this illustration shows we start with a pair of babies that are not fertile. That is the number 0 in the sequence. Those babies then mature and become fertile adults. That's the 1. The next one is that now fertile pair has a pair of babies. Those babies become fertile adults. Now there are 2 pairs of fertile adults. They have a pair of babies. Now there are 3 pairs of fertile adults, and so on. You get the idea. But what has this got to do with nature other than rabbits? Well, it turns out that many things in nature have these numbers represented. Many flowers have 3, 5, or 8 petals, for example. You'll see these numbers all over. The other common pattern is a spiral, like that of a snail shell. We've all seen this, but where does it come from? It's essentially a visual representation of this same series of numbers. Let's see how this curve is derived. Let's use boxes to illustrate this. Like the number sequence, you start with 2 squares of the same size, 1 and 1. The next square is 2. Next is 3, and it just happens to be the same size as the 2 previous squares combined. Continue this through the series of 34. Next, draw an arc that connects the opposite corners of each square. That arc is a portion of a circle, not just an ellipse. This is the spiral that we see all around us. I hope you have enjoyed this little video as much as I enjoyed putting it together. Thanks for watching.